have a look at lesson 39. Lesson 40 tomorrow, test review Monday, test on Tuesday. Okay, so your Unit 4 test is next Tuesday. Sorry, we're going to have to move that because we don't have class on Monday. All right, so maybe we'll make some adjustments. We'll see. I'll tell you tomorrow. We may still have a test on Tuesday. All right, today we're learning to use the distributive property to simplify rational expressions. Now, what do we mean by rational expressions?
Expressions that are rational.
What do we mean by rational mathematically?
Something over another.
Something that's in the form of a fraction, right? A ratio, yes. Now, a ratio, there's the key word, ratio, right? Ratio is the kind of the root word of rational, you know. Yes, so it is a ratio. Now, a rational expression generally is different from a rational number. Okay, a rational number is a number that is or can be written as a ratio. And a rational expression is something that involves variables. Okay, yes. This is lesson 39. All right. Now, let's have a couple of things here. And I just said this. A rational expression is an expression that has variables in the denominator of the fraction. Okay. Rational expressions are treated just like fractions. We can add them by getting common denominators. We multiply them the same way. We divide them the same way. How do you divide rational numbers? How do you divide fractions? Keep the first one, you flip the second one, and change division to multiplication, right? So all of that's the same. As with fractions, denominators cannot be zero, so we got to kind of consider when we're talking about rational expressions that denominators cannot be zero. And if there's a variable in the denominator, that means that any variable that's in a denominator also cannot be zero. Can't be zero. So we're going to talk about excluded values. Okay, so that's what that last bullet point says there. All right, so we're going to be today primarily using the distributive property to simplify rational expressions that look like this. All right, they're going to start easy, right? We'll get a little bit more complicated as we move through this. What's the rule for multiplying fractions? No, that's the rule for exponents. What's the rule for multiplying fractions? Numerator times numerator, denominator times denominator. So if we want, another way we could say that is top times top, bottom times bottom, right? We're going to distribute and multiply each one of these. So x squared will be multiplied by that, and it'll also be multiplied by that. Now, what do we get when we multiply the first terms? X to the fourth over y to the third plus 3x squared y cubed over my squared. Yeah, you could say y squared m. You could say y squared m, but there is, a standardized expression. Let's keep our variables in alphabetical order. Sit up, guys. All right. Now, can we do anything else with this expression? Yes, that's exactly right. Because we have y values there that can be simplified, nothing can be simplified in the first term, but in the second term, y cubed over y squared is going to give us y to the first over m. Now, can we do anything else? We can't. What's up, Hadley?
Can you cross, I know this isn't multiplication, but can you cross, there's a y cubed in the denominator and a y cubed in the numerator?
It actually is multiplication, so you could cross cancel during the process. And that's going to be easy to do in simple problems like this. The ones that we're about to look at coming up where you have a bunch of negative exponents, and maybe it's easier to do it later. But yes, you do have the option of cross canceling when you're multiplying. Right. Yeah, but this isn't addition. That's multiplication. Right? Now, Right. Oh, no. Can we add these? No. So you were talking about there. Can we cross cancel?
I was talking about how there's like a y cubed in the denominator of the first one, want to distribute, and there's a y cubed in the numerator of the second one. I was wondering if you could like cross them.
No, because this is addition. When are we allowed to cross cancel?
Multiplication.
You're only allowed to cancel factors when you're multiplying. Okay. Can we add these two terms together? We cannot because the denominators are not like. This lesson does not involve getting a common denominator and adding these two expressions together, but that's coming soon. Okay. Next example. Now this is the same as the last one. I don't know why they kind of make a big deal out of a difference between addition and subtraction. That's just a signed number, right? We're going to, one of the things that may be a little confusing here, if you have rational expressions, I think maybe sometimes it helps some people to show that as a rational expression also, just to make sure that you're dealing with numerator, denominator correctly. You don't have to do that, but you can. All right, now we're going to distribute again. This times this times this. What do we get when we distribute the first terms? Yeah, MAXP. You could put that in alphabetical order if you wanted to, but I'm going with what you guys said. Over MKZ minus 2M to the 5th P to the 4th over Z. Yes. All right, now can we simplify anything? The M's can be canceled here, and we're left with APX over KZ minus 2M to the 5th P to the 4th over Z. Again, really simple. It's just more of what we've been doing before. Okay? Now, what about negative exponents involved? There are a couple of ways to approach this problem. I'm going to encourage you to do it the way I'm about to tell you to do it. And that is to, before you do anything with your problem, make all of your exponents positive. Okay? So if it has a negative exponent, we want it to do what? Cross a line and change the sign. So this will be B to the 3rd, D to the 3rd. I'm going to keep it in a rational form and go ahead and write it that way. The next term is fine. It's 2B squared over D. And then the final term will be D over BF cubed. This is it's just easier to deal with in this form. Could you multiply it and then make all the exponents positive? Well, of course. Okay, but if you do it that way, the option to cross cancel while you're multiplying becomes a lot more confusing. So we do have the option to cross cancel as we multiply. If you have negative exponents, that's not necessarily going to be helpful to you. All right, so let's distribute now. Distribute this to this and this. What do we get in the first term? 2B to the 5th, D to the 3rd over D. Now, could we have cross-canceled those D's while we were multiplying? And that would have left us with D squared in the top, which is what we're going to get in a second. I'd rather you be, at this point, I'd rather you be safe than try to do it quickly and make a careless mistake. All right? Jay, what do we get when we multiply the second terms there?
We get B to the 3rd.
Okay.
D to the 4th.
All right.
Over BF to the 3rd.
All right. Good. All right. Now we can simplify some things, right? I'm running out of space, so I'm going to erase and simplify here. The D cubed and the D will give me what? D squared up top. You can put 1 in the bottom. You don't have to. Flores. Thank you. All right. B cubed over B here gives me B squared up top. All right. Can anything else cancel? All right, that's our final solution. Wait. You sure?
Yeah, it was the same answer, but I think you did some stuff and like erased it.
Yeah. Are you good? Okay. All right. All right. Try this one on your own. Okay? Bo, talk me through it.
Okay, so you said that you want to get the negative exponents positive.
I think it's a good plan of attack. You don't have to do it that way. You can distribute things as they are and work with it, but I like that plan of attack.
Okay, so you're going to flip n to the negative 1 from the bottom, so you have 1 over n.
M-N, good.
Cn, you flip Cn negative 3 and P negative 5.
Okay.
So it's that over 1. All
Yeah.
that is.
M-N to the third, P to the fifth, X over C. Good. Plus,
Plus, you should move that n negative.
right? So that'll be 5 over N to the fourth, P to the fifth. Very good. Well done. What's next, Cooper?
And then you distribute, and you get mn to the third x p to the fifth over mnc plus 5 over mn to the fifth p to the fifth.
You said N to the fifth, P to the fifth.
Yes, sir.
Okay. Now, there's nothing we can do to that second term, but we can cancel one of the N's and the M's, right? So what's that going to give us? Both the M's are gone, and
N squared.
N squared.
P to the fifth x over c.
There you go. N squared, P to the fifth X over C, plus 5 over Mn to the fifth P to the fifth. Well done. How'd y'all do on that one? Good, good. Now, that's what I'm saying. It's not difficult. It's just it's tedious. The little steps you have to take. It's following the bouncing ball, and that's why I'm encouraging you, have a plan. What's the first plan? What's the first step in our approach to a problem like this? Make the negative exponents positive and then distribute and then simplify. Okay, so having a plan of attack is always going to be helpful to us. All right? Now, what's different about this problem? We're distributing one term to 3 terms instead of to only 2, but that's just more the same. This problem is actually easier than the previous 2 problems. All right, we're making 3 distributions. What do we get when we distribute the first term? A squared, B squared, X over C cubed. And the next term, let's make sure we recognize that there's a denominator there, right? Let's do 2AB squared X over C squared. And then the last term is going to be minus 4 over C to the fourth. I guess that's it. We need to check and make sure nothing can simplify. That's it. All right? Any questions there? All right, last example. Try this one on your own. All right. So let's take this step by step. First thing is to simplify each piece of the puzzle, make all of our exponents positive. What will that give us? G squared. All right, hold on. This next term will be dxh over g squared minus. Okay, plus. Yeah, the over 1 doesn't have to be there, but again, I think it just kind of helps to have everything in fractional form, right? If you're multiplying fractions, it's just easier to see everything in fractional form. Now we're going to distribute, right? We're going to multiply that by all three of these. And that's going to give us, for the first term, what? D. Hold on just a second. One person talk to me. Go ahead, Hadley. D.
dg squared h to the second, or h squared.
Over.
X over d squared g squared.
All right. Minus.
Wait, there's an X. There's an X. You said X.
Oh,
Yeah, sorry.
No, Hadley did say.
I just forgot to put it. It's okay. Let's move on.
minus 2g squared h to the fifth over d squared x
Okay.
plus 9g squared d cubed h over d squared.
All right, now we just have to simplify each of these terms and we'll be done, right? So what can cancel in the first term? The g squareds are just gone, right? And one of the d's. And so we're left with h squared x over d. Right? And the next term, can anything cancel? So we have 2g squared h to the fifth over d squared x plus 9 dg squared h, if we want to put it back in alphabetical order, over 1. Does the over 1 have to be there? No, does not. It's optional. Now, is 1 optional in the numerator? No, 1's not optional in the numerator. If it's a numerator, it has to be there. What's up, Liam?
You said it would be better, but would you count off if we didn't put the variables in alphabetical order?
I will not. It's just going to be easier for us to communicate about what the correct answer is. Like when we check homework tomorrow, just imagine if I'm calling out the answers and they're in alphabetical order and yours aren't. So it's just a matter of standardizing things to have your variables in alphabetical order. I mean, some of the problems that we've worked here, I think maybe the final answer that we wrote down didn't have it in alphabetical order. It's something that you're going to forget. I'd rather you get the problem right than to focus on that and miss something. Okay, so yeah, it's just a proper form. Karis.
Are you gonna like count off if we don't like change the negative exponents first?
I'm not, but if you miss it, I'm going to point you to that method. It just gets a little bit confusing when you start doing this that way, and not so much this skill, but some other skills. As a general rule, it's a good habit to make your exponents positive before you simplify or do any operations. You'll see more and more examples of this. No, it's just my prescribed method to make your exponents positive before you do these operations. You can, because you have to do it eventually, right? So if you multiply and then change them later, you're not saving yourself a step. Okay? All right, now there are some shortcuts. You can cross cancel when you multiply. You can add exponents even if they're negative. But to me, it's just an easier process. Make your exponents positive and multiply and then simplify. There's your homework, page 246. Write this down, but we're going to practice something before you start actually working on your homework. For our quiz tomorrow, solving equations and proportions, we're going to practice something here. But this is your homework for lesson 39.